Hi, welcome to Algebra. So, as you know that actually we are purely technical training institute. Okay, it's all engineering kind of courses only we dealt with it, actually, especially related to civil and as well as mechanical MEP. It's all related to design course, including the quantity surveying, and not limited to, we do have Rivet as well. Okay, so let's focus on why we are here. Actually, we only concentrating on the structural design course, right? Actually, fantastic. Okay, the structural design course, especially we are going for manual calculation. So as I feel personally, rather than going into the software directly, actually, of course, you need to go into the softwares. I mean, I'll tell you why you have to go to the softwares, why we have to learn to the manual calculation. Okay, let's keep aside the municipality examination. Okay, because the people are only focusing for the municipality examination. I need to go and attempt. I need to make it pass in order to get G+4 license. Okay, so that's a different story, because the thing is what actually people nowadays actually once I acquire the license, I mean I can go on market to get the jobs. So that kind of propaganda has been only. So my understanding is actually the moment when you learn the manual calculation, that is the basic concept which you can build your structural career into it, go for to do your complete structural design and analysis. You get my point? I mean, so the one who doesn't know and who doesn't have any concept in order to learn the manual calculation, then whatsoever you do, actually, I used to say always there is what do you call statement, garbage in, garbage out. You use any kind of software, doesn't matter. Today there is a software called E.X.L. Tomorrow you do have some other softwares like what do you call Midas, okay, and we have used in India actually G schedule, 3D actually. So those kind of structural softwares we dealt with it. Whatsoever you use, it's only the interface is going to be get changed coming, but rest other what it is exactly is been doing, and right behind of the software which is called FPM analysis, finite element method analysis, it is also. You get my point actually. Okay. So in order to make it very clear, I'll just give you in a small statement. There are two kind of structures. One is what actually determinate structure. Another one is indeterminate structure. So the people even are getting confused with this kind of things. Of course, it is a theoretical statement actually, but this theoretical statement, until otherwise, if you don't understand in a very bit of clear actually, you cannot apply into the whole design concept. You get my point? So let me talk about what is determinate structure. Say for example, I have a truss. Okay, I have a truss, and I have what? I have 3D frames. Okay, 3D frames. So assume I have a truss having the pinned support. Okay, and I'm going to apply 10 kilonewton forces on top of it. The moment when I apply 10 kilonewton forces, I need to calculate the member force. Say for example, actually, this is what actually, this is the tension member, correct? And this is what? Compression member, isn't it? And these are all diagonal member, which is going to take the bit of shear, isn't it? Okay. In such case, what is, say, this is the simply support. Assume this is what the people are making themselves confused. I mean, if I say tension member actually, then they will just take it as tension member for completely. It is going to be different from support to support. Okay, since it is a simply supported, it's going to be as a tension member. If I'm going to have a continuous member, then the tension member is going to be changed. Get my point actually. Let's focus I don't want to confuse you. Say for an example, this, if I know this degree, say for an example, 15 degree, 20 degree, so I can easily resolve these forces to calculate each and every member forces. Okay, by using what? Pythagoras theorem, isn't it? By using Pythagoras, saying it is tan theta, the tan theta equal to what actually? The adjacent side by what do you call actually? Hypotenuse. Okay, or opposite side by adjacent side. Whatever it is actually, I can make it these three propaganda in order to calculate each and every member forces. You get my point? But the moment when you come to 3D frames, say for example, I have 6 columns, okay, with 6 beams connected. The spacing between the columns, assume if it does not change, okay, if it is not going to be same as one bay to another bay, then it's very difficult to calculate. Though you can say, no, sir, I can take it each and every frame, I can calculate myself actually, it's fine. It's not a big deal out of it. Then I'm going to apply the lateral force. Assume I'm going to apply the wind force, or I'm going to apply the seismic force. The moment when the lateral force comes, and these forces is not going to be same as is for this column and this column and this column, this column. You get my point? We can only play around for the gravity load. Okay, the one who does the design by using the gravity load, that's not the design actually. I'm really sorry to say you this, because this is what I used to say always. Okay, the people used to say so I know how to design the buildings actually. Okay, I know how to design the values. I know how to design the what they call for the annexure structures.
or ancillary structures actually. The thing is what I mean, the one who doesn't understand in terms of lateral force. Note this point actually. I only said lateral force. Lateral force, it is two things. One is wind and another is seismic. Okay. So the behavior in order to get it, the behavior in order to have like the complete structures or complete steel structure or the whole RCC building, the moment when you apply the lateral force only you can get it. You get my point actually. The behavior of the structure, if you want to understand, then you have to apply the lateral force. Okay. This is what actually, it is not the beauty to design like G building or G+1 or G+2 structure. You need to understand and go a bit of more concept to design the high risk structure. So the moment when you design the high risk structures, then you will go more in deep to understand the structural concept of each and every bit. Okay, let's focus on a very small example. This is what? This is the simply supported beam, correct actually. So I just made it like, assume this is the supporting columns and this is the supporting beams, correct? Yes, isn't it? Simply supported beams is what actually, by general we know that the bending moment is what? Zero. Okay, but when I go reality, if I say these two columns, actually it is not. Actually, this is like this. So I have a negative moment, I have a negative moment, I have a positive moment. Whatever it is say, you say sagging moment, hogging moment, positive, negative, doesn't matter actually, but there is a moment, correct actually. This is the top moment and this is the bottom moment. Okay. And the moment, what it does actually, it is going to be create indirect tension force. Indirect tension force. How? Tension force equal to moment divided by lever. These are all not equation. We need to understand. These are all not equation. This is the basic structural concept. You try to understand actually. Okay. The people are like, why they are confusing themselves. Whenever we wrote something, in order to have equation, actually, they said this is the formula. We need to buy heart it. In order to go into deep, you need to understand those equations to make it in terms of core concept of structure. You get my point actually. So the tension equal to moment divided by lever arm. Okay, in order to make it very clear, I said actually this is not the equation, correct? So when I said this is not the equation,
I'll make it another diagram to explain about this. Okay, this is the 2D frame, correct? This is the two 2D frames. The difference is what actually this has simply supported and this has fixed supported. So I have a load, assume I have a UDL load, I have a UDL load. Okay, what is the forces are you going to get it here? You will have a compression force and you will have a tension force and you will have a shear force. Okay, and moment is zero. Okay, let's focus here. So you will have a compression force, you will have a tension force, you will have a shear force, and you will have a moment tension. Okay, the only difference is what between the simply supported and fixed support actually. Everyone knows the basic funda is what? There is a moment. Rest other it is same. But if you go in deep, is that only the difference or there is no difference else except the moment? If you ask me, remember actually there is no load change. Okay, the UDL which is going to be applied on top of the beams, it is same. It means what? Whatever the bending moment which you're going to get it here, it is also same, isn't it? Okay. Since it is a fixed, what the bending moment you do have in the beams, whatever the bending moment you do have in the columns, the partial portion is going to be transferred to the base because it is the fixed support. Here, it is not going to be transfer anything. It is zero. It means what? If I'm standing, if you're going to push me to my body actually, if my body is going to be resist 80 kg, okay, and no moment is going to be transferred at the base in the sense actually, the whole body is has to be resist those applied force. Correct? Yeah. The moment is what actually someone is catching my leg. Correct? Actually, pinned also someone is catching. The catching point is different. The before someone is catching my foot. Okay. The fixed is actually someone is catching my ankle. Okay. I'll give you the free simple example. Actually. Before someone is catching my foot. If I may catch my foot, actually, I'm freely rotate. You get my point. The moment actually I take my hand little bit half a feet above, I'm going to catch my ankle. If I may catch my ankle, actually, I cannot freely rotate because this guy has been holding my leg. You get my point. The moment he is been holding my leg, actually, either it could be 20% or 25 or 30%. Somehow there is a moment which is going to be transferred at the base. Okay. The remaining forces only is going to be resisted by what? Superstructure. In that case, what is going to be happen? If the remaining force is going to be resisted by the force, by the superstructure,
though this load is not going to be changed, in that case, I can optimize this member. I can optimize this memberage. Here, the whole force is going to be resisted by the superstructure only because you are not doing any moment to the base. The moment when you're not allowing any moment to the base, in the sense what is going to be happen, those moment also is going to be resisted by the frames. Then it is very crystal clear, your member size becomes bigger. Here, member size becomes smaller. This is the basic funda in order to go for whether I need to assume the simply supported or fixed support. People doesn't understand actually, like, what kind of support up till now they need to assume with respect to the structure. You design it either RCC structure, you design it either steel structure, you design it either aluminum structure, doesn't matter. Okay. The basic fundamental is what actually, which support condition do I need to go for it, I mean, in order to design it. You don't know. What they used to think actually, I know ATAR's model, I know safe actually, let me build up actually or apply the load, I've done the design. Okay. What you're going to do, software is going to do everything, sir, actually. So what we wanted to do. I'm giving the sizes actually. Software is showing whether it is fail or pass actually. I will extract the forces. I'm just giving to you. You get my point, I mean, okay. But that's not the story. The story is what actually you need to understand each and every bit, I mean, while modeling along with the structural core concept. Okay, that's what we are here. Correct, actually. If you don't understand the core concept of manual calculation, there is no use. Again, garbage in, garbage out. I'll give you another example. Let me focus, I mean, okay. We understand, right? What is the support condition of fixed and field? Okay, let me go for the same, the first question when I written actually for simply supported beam. Okay, so I'm going to design this beam. Assume it is steel beam or RCC beam or aluminum or timber, doesn't matter. Okay, the analysis design step is not going to be changed. You get my point? Either the code is going to be changed, okay, or the coefficient is going to be changed, or parameters is going to be changed, okay, related to this, either somehow the equation is going to be changed. But till it was analysis, it is same. Till to the structural analysis is same. So the moment when you understand, when you got the moment actually, I can come up with the steel section, I can come up with the RCC, I can come up with the wooden section, I can come up with the aluminum section. So what you need to get the forces. For that, you need to understand what exactly do I need to apply the load on top of the structure. You get my point? Okay. Let me move the screen.
Mr. Manish. Screen. I need to move the screen. Yeah. No. Okay. Assume I'm going to design this concrete beam. Huh? Assume I'm going to design this concrete or steel again, whatever it is, irrespective of any material. The first most thing what I need actually, I need to assume what actually the section sizes. Assume this is 2. The first most thing is what? Material properties. Anything. You go for RCC, you go for steel, you go for aluminum, doesn't matter. If I go for RCC, I need what actually? The concrete grade, right? Another one is what? Rebar. If I go for steel, what? Then I have to go for structural steel yield strength, right? Structural steel yield strength. If I go for aluminum, it is a vice versa. Aluminum yield strength. If I go for timber, it is same edge. So what is the bending strength and shear strength of timber edge? Okay. So that's most important. I need to go for the initial assumption of material properties. Okay, be with me. This is the quite important fundamental. Okay, in order to understand the manual calculation. The moment when you understand these steps, I mean, and whatever we are going to see in further, either it could be column designs, flat design, wing frame analysis, crack with long-term deflection, those kind of things, it could be very easy for you. Or else what you do, you will only by heart the equation. and that is not going to be exist forever at all. Might be, it might require only to pass the examination. In other words, actually, it won't help you for your future career at all. I'm really sorry. Okay, but that's what fact. That is a fact. If you want to really, like, to make them and understand, to implement in your future, actually, be with me. This is the very important one. Okay. The first most thing is what actually? Material properties. Okay. The material properties is what actually? The concrete grade, which is what? C40. Why it is C40? As per municipality requirements. Any kind of municipality, either it could be Dubai municipality, Sharjah, Abu Dhabi, Quain, Ras Al Khaimah, Takhiz, anywhere actually. The minimum concrete grade you have to assume for what? C40, which is cubical strength. The minimum concrete grade you have to assume for C40 cubical strength. Now the question comes, since none of the municipality is accepting to design by using British standards. Okay. So in that case, I have to use it what? American standards. Okay. If I use American standard, this 40 is belongs to what? British standard. Correct? The cube test in generally, what we used to do inside actually, it is basically what? It is according to the British standard. But American standard is referring to what? Cylindrical strength. Correct? Okay. Then what is the correlation between this actually? So FC dash, FC dash or FC prime, whatever you can call it is, equal to 0.8 into FCU actually. So what I'm trying to say, you can just keep it in other ways. 20% always less by cylindrical strength. Okay. 20% it is less by from the cubical to cylindrical. That's what the simple we call understanding the things. Okay. I'll go for like what do you call actually modulus of elasticity. Modulus of elasticity is very simple concept, like the ratio between stress and strain actually. Don't go in deep actually. That's a bit of like the equation actually, and you don't need to buy heart it. Okay, just write it. This is the ratio between the stress and strain. 4,700 root of FC dash. Okay. And what is the rebar? I don't want to go in very basic rebar. You all know that, right? Actually, either it could be 460 or 500. Of course, not more than 500 because municipality are restricted actually to keep it like only 500. You can go for more than 500. It's supposed to be like chromium steels actually, or it's a kind of special MMFX steel is there. There are there in the market actually. It's called what? MMFX rebar. Okay, this MMFX rebar is actually which has in generally high yield strength, high tensile strength. Okay, normally we used to use in pile. Okay, where especially in pile actually you'll have like so many congested and the congestion of rebar. In that case we used to go for like MMFX to increase your yield strength, tensile strength in order to reduce your reinforcement. You understand, right? If you have any question, please stop me and you can ask me anything. No problem, doesn't matter. Huh? Okay. When you go for structural steel, actually, and this could be same, which is PY or FY, doesn't matter. This is only notation. So we do have in general three grade, 275 and 375, 275 and 355. We have further grades as well. We don't use it actually. Since we dealt in recently, like Dubai Metro Line project, there we are went for like 450, 550, 650 yield strength. Okay, that's only for special case. I'm getting, that's only for special case. It's very difficult to get it and acquire in the market. Those kind of material. Okay, so in general, if you can see in the whole UAE market, these two yield strength of material which is readily available, you can get it 275 or 355. Is that clear, right? Okay. Let me go for section sizes. So what are the section sizes which you usually go for? Okay, I'm not talking about in terms of beam alone. I'm giving like general concept. Okay, the section sizes what actually I have to assume for columns. I have to assume for shear walls. I have to go for beams. Correct. I have to go for slabs. I have to go for foundation. Only we do have what 5 elements. That's it. The whole structure actually, if we talk about, they have only 5 elements. Either it could be columns, either it could be shear wall, either it could be beams, either it could be slabs, either it could be foundation. Of course, foundation, you do have different kind of foundation. Let's not talk into it because we'll just discuss in general, try to understand in terms of design principles. Okay, I don't want to go in the first class actually in a very deep. Okay, so that you will get like feel bored. Okay, so let me just go for in general. So yeah, slowly we have to go for it. Correct actually. If I go directly into the this is what the people hate designs. People frustrated design actually. If I wrote like so many couple of equation and start mug upping, start by heart the things actually, then you don't like it. Because design, it won't come like this. Design in the sense actually, you need to understand what, you need to understand the concept, you need to understand the basics, you need to understand the fundamentals, you need to understand how the design principle, how the structure is going to work. That's a design. Okay. It's not about by hearting the equation. If I know 100 equation, if I know 50 equation, someone says actually, sir, I know all the codes. It is important actually because the code is open. You get my point. Whenever you want, you can refer the code actually. You get my point actually. So only to write the examination, yes. To write the examination, you do actually just write it and practice it, go for the examination. But doesn't exist when you go for your career. Just try to understand actually. If you don't understand and a bit of manual, this is what we used to say again and again. Okay. If you don't know even a simple beam, how you need to design it actually, it's not that fruitful, being, I can say I'm a civil engineer. You get my point. Now the civil engineer becomes changed actually. Whenever I used to go home and our neighbor people, they used to ask actually, so what is your son actually? Our son is civil engineer. Can he able to draw the plans? So they become, our civil engineer become architect. You get my point actually. Can he able to do it my home plan? Can he able to develop the elevation? Can he able to do this 3D? You get my point actually. Oh, civil engineer has a different disciplines actually, and a different sections are there. But the thing is what? These are all basic fundamentals, though wherever you are, doesn't matter actually. Sir, I have to continue my career in site. Continue. I have to continue my career in QS. Continue. I have to continue my career in TC, QA/QC. Okay, site engineers, project manager, construction manager, structure. Doesn't matter. Wherever you're there, actually, the moment when you understand this technicality, it helps a lot when you sit in a meeting in front of consultant, in front of what actually, in front of the client as well. I'll give you the the real example where I worked in a company. There is a guy actually, he's a QS, quantity survey. Okay. There was a 4 project actually, which has been came to us as a tender. Okay. Fortunately, what actually the client and the contractor owner where I was worked actually before, quite long before, like you actually when I started my career. Okay. These guys are know each other. And they said actually, I'll give you this project. Once the price is competitive. Okay. So what is this 4 warehouse? This comes around I feel that time 120 million, 130 million. Of course, client is client actually. Just kya hai yaar, actually they do you just give me discount. Okay, it's kind of like. Of course, contractor discount, you know that, right? 10 to 15% they used to keep it margin, correct? 10% nowadays in the market actually, if you can get it 10% is fantastic actually, but 10 to 15% they used to keep it. So what he did actually, he has given 5% discount. You are getting my point, right? Okay, 5% discount. The client said, fantastic here actually, I'll just move forward. But fortunately, what happened? There are so many the Bengali peoples are there in the market. You know that, actually, correct? I mean, so I want to say the name of that. So they have given the quotation. We don't know how they are going to achieve those prices actually. It's 20% less. And to be honest, we don't. You get my point. The same specification, same painting, same galvanization, okay, same beam, same section actually. I don't know where they're going to get it actually. Are they going to get it from Mars? I don't know. You get my point. So 20% less. We claim, yeah, what is this here actually? You have given 5%. You only ask 5% actually. I have given 5%. Now this guy is being given 10% more. Okay. So 20%, but he has given 10% more. So 5% is not going to work actually. Give me 5% more actually, then I'll award this project to you. Okay. Then what he decided, he came and he discussed with us, but I was not there, to be honest. It's a real example. Okay. And he discussed to the other teams. Okay. So what we have to do, of course, he will discuss with the commercial team and the QS team, because when the price comes in upfront, then they said actually, we cannot take this project because if they ask 5% more, you will only get 5% actually. And this 5%, till to finish the project, there are so many foreseens, unforeseens is there actually. Then you will not get this profit at all actually. While doing the construction, you will have so many things. Okay, ups and downs. He said, don't take this project, leave it actually. But there is a quantity surveyor, remember, quantity surveyor guy who came into the front who said actually, take this project. Okay, if you take this project, and upon one condition, as client, we can do the value engineering. Okay. If they allow us to do the value engineering, we can give 10% more, not 5%, 10%, which is 15%. We'll give 15% more. On top of it, we'll get 10%. It means total 25% savings. What he's trying to say, total 25% savings. The client, of course, is a non-technical, he doesn't understand actually. And he don't want to listen actually because it came from QS. If it does come from design, actually, it makes sense. Correct, actually. Then was said actually, no, this guy is bluffing. We will leave this project. Then we came into the picture. He said, I mean, aisa bol raha hai yaar. He was saying something. Can we take this project actually? I said, what he said actually. If we allow us to do the value engineering, okay, we are not going to change the load. Huh? We are not going to change the load. Load is same. Huh? Try to understand. Load is same because you are not authorized to change the load because it came from the consultant. So what he said actually, only to do the value engineering. Okay. Then we said, like, we know that what basis he said actually, still we asked actually. So how you said actually, like, to come up with the value engineering, since you're not going to change the load, okay, if you don't change the load, section sizes is not going to change. Section sizes is not going to change. If section sizes is not going to change, the tonnage it remains same much. If the tonnage of steel it remains same, then how you are going to say which we are going to get it on top of it 10% extra? Correct? Okay. For that, you need to understand the basic fundamental is what actually. You might have seen this, right? Correct? Okay. This is a plan view. Huh? This is the plan view. Okay. We can see the elevation view, and this is the columns, and this is the base plate, correct? This is the pedestal. This is the foundation, isn't it? This is the foundation. This is how it is going to look like. And I have what? I have the anchor bolt. But I have an anchor bolt. Let's come into the other chapter for the anchor bolt actually, because you do have different grade of anchors. Okay, I don't want to confuse you. Okay, this anchors, which is talking about this. This bolt, either it could be inside the section or it could be outside the section. Okay. As I said before, like, if you have simply supported, I have a compression, I have a tension, I have a shear. Let's not talk about this compression, tension, shear at all. We'll only focus on moment. We'll only focus on what? Moment. In fixed, you have moment, right? In simply supported, moment is zero, correct? Okay, fantastic. Assume the moment is what? 100 kilonewton meter. Assume what? Moment is 100 assume moment is what? 100 kilonewton meter. As I said, is what? The tension force equal to what? Moment divided by lever, M by Z. Okay. Of course, this bolt is away from the section. Okay. I can see the section sizes, let's assume 200 millimeters. Okay. Same here also, 200 millimeters. Okay. And the bolt is little away from the section actually. Assume 50 millimeter away. So which is 200, 50, 50. Then this is what? 300. Correct? Yeah. And this is inside the section. Of course, 50 inside actually, assume that it could be what? 100. The one is 100, another one is what? 300. Okay. Then tension force equal to moment divided by lever arm. The moment is what actually? Assume 100 kilonewton per meter. I'm talking about the fixed support. Huh? Fixed support. What is the lever arm? Why it is lever arm actually? Why it is lever arm? Okay. Assume the guy is standing. We're going to apply the forces. Okay. Practical example. We are going to apply the forces. What? You're going to hit his head. Huh? You're going to push head. Assume something like 50 kg, you're going to push the head. So what is going to do? This guy is going to fall down, correct? When it's going to fall down, the one will go for compression, one will go for tension. Imagine it. There are two legs actually. If you're going to push me, then I'm going to fall down actually, but one automatically will go down actually, one leg automatically will go up. So one is compression, one is tension. So between this distance is going to be convert these moment into tension force. That's called lever arm. That's called what? Lever arm. Any kind of structure, if you could see in practically, if the bolts are away from the section, it is fixed support by default. Okay, to make you understand very clearly for fixed support understand. Any kind of structure, any kind of section, if you could see practically, the bolts are away from the section, it is what one? It is by default, it is a fixed support. Any kind of structure or section, if the bolts are inside the section, by default, it is called what? pinned support. It is simply support. Okay. So when it comes to this point, the moment is what? 100 divided by Z is what? 300, right? 0.3 meters, isn't it? So how much it will come? 333.33, right? 333.33 kilonewton, which is nothing but 33.33 tons. What is T? Fantastic. Correct? You're going to apply the force here, right? Actually, what is moment? Force into distance. This is the moment funda. Okay. The force P multiplied by the distance is called what? Moment. When this moment is going to be happen, so what is going to do? One leg will be under compression, one leg will be under tension. I have to resist him. You apply the force on top of the head actually. This guy is going to fall down. I have to resist actually. If I need to resist, I need to know what is the tension force.
Yeah.
If you don't know what is the tension force, you cannot resist. Isn't it actually? Though you have a capacity of 80 kg, but someone has to hold, right actually? Isn't it? Someone has to hold your leg actually in order to make it your 80 kg. So those you're going to come under tension force. This is called what? Tension force. So tension force equal to moment divided by lever arm. Okay. I'll give you another things actually. I'm really sorry to interrupt you. The people are trying to understand the direct tension is much more important, or I need to give the importance to the direct tension when compared to what? Moment. Because people don't have an understanding of the moment seriousness, then whenever there is a direct tension comes actually, then they will just more fond of, more into the pot of direct tension. The moment is very critical than the direct tension. You get my point? Okay. Assume I have a direct tension. Direct tension, 100 kilonewton. Okay. The moment is what? 100 kilonewton. People, what they used to do? Assume even if it is moment is what? 80 kilonewton. When compared to 180, 80 is small, right? Actually, people will directly ignore. I'll take only the 100 kilonewton. You get my point actually. But this guy is worse than the direct tension. Because this guy, if you try to resolve with the distance of resisting the forces of distance between the bolt or distance between the section, it is much more higher, 333.33, much more higher than the direct tension, 3 times higher. Though the moment is less, only 80 kilonewton. Moment is less, but the result is what? It's much more higher. Now the question comes, sir, you are giving the example for steel structure. What is going to be happen if it is RCC? You get my point. What is going to be happen if it is RCC? Assume there is a column, there is a beam. Okay, this is the cantilever. Huh? This is the cantilever. You know that if it is a cantilever, the moment is going to be act as support. Correct, actually? Yeah, the whole moment is going to be transferred to the support. In that case, which is the what do you call the lever arm? The distance which is going to be resist. This is the guy. This is the guy. Because if the beam is going to fail, the whole beam is going to fail. Correct. The whole beam is going to bend. The whole beam actually. Then this is the distance which is going to be resist actually in order to come up with what is the tension force. So tension force equal to moment divided by lever arm. Again, if it is a moment is 100, assume this distance is actually 0.33, then 333.33 kilonewton. Okay, 333.33 kilonewton. I need to design for 333.33 kilonewton the rebar on top of it. For that, you don't need to use any software. You get my point actually. I'll give you another simple example actually. 8 millimeter rebar or 10 millimeter dia. There are two kinds of rebar. I have the capacity of 1 ton, the load. I'm asking you to lift this 110 actually, either I could use it 8 mm or 10 mm. How do you calculate? You get my point? This is not the design. For that, you don't need to use any software. This is where it comes under the manual calculation. This is where it comes under the manual calculation. To calculate, in order to take the capacity of 110, whether I need to go for 8 mm or 10 mm or 12 mm or 16 mm actually, I don't need to use some software actually to calculate. The basic funda is what actually? Area of the steel by yield stress. That's it. This is one of the basic questions in municipality examination. One of the basic questions. Area of steel by yield stress. This is the concept. This is not the equation. When you do have the area of the element, when I multiply the corresponding yield strength, I will get the capacity. I'll get what? I'll get the capacity. The similar way, if I go for weld, it is exactly same. Okay. Again, area of yield stress. The weld capacity also it is same. So by keeping this concept, I can calculate anything. I can calculate timber, I can calculate steel, I can calculate bolt, I can calculate what you call actually. Even the rebar, doesn't matter. But the equation, it's not an equation, it's not a formula. It is a basic fundamental actually. If I know what is the rebar area, if I know what is the rebar, what is the area of the section, if I know what is the area of the element, multiply with the corresponding yield strength. If I go for structural steel, I could use it to 75, correct actually. There are 355 also is there. When I multiply, I will have like, what equal capacity. You get my point, what I'm trying to say actually. Okay. So coming to the point is what actually, the first one is material properties. The second one is what section sizes, which I said column, shear wall, beam, slabs, and foundation. Correct actually. We will show you in the next class actually, like, how do you assume the section sizes, assuming like, what is the slab thickness, what the code refers. You get my point. I don't want to give you like, any thumb rule, any reference. Here we are not going to deal with any thumb rule. Whatever it is, actually, it is according to the code. It is according to the AC. It is according to some other reference. You get my point. If I don't give you this thing actually, then if I give you only randomly for thumb rule, it doesn't help you for your career. So what you will do actually, you will keep it same thing on me. If someone will be like, keeps asking like, how do you get this number? How do you get this equation? You know the answer. The moment when you do have reference actually, then you don't ask anything. You get my point. Okay. So those things is what actually section says. If you want note down actually, I will remove this. Okay. And yeah, by closing this, what I mean. So as I said, actually, this is a fixed support. The bolt is away from the section, which you are getting the forces is what? 333.33, right? And if you convert into kilonewton to tons, 333.33 tons. Okay, because kilonewton to ton actually you need to divide by only 10. Okay, 33.3. Assume in field support also you have a moment. Assume. So 100 divided by what is the distance? 100, right? So which is 0.1 1000 kilonewton, 100 tons. It's almost like 3 times higher than this. Okay. The basic funda is what actually, if the legs are closed, if the bolts are closed, okay, if those resisting lever arm is closed, actually, it will never take the huge moment. In order to transfer the tension force, in order to resist the moment, it has to be like, away from the section sizes or away from the lever arm. Correct, exactly. If you just go for the maximum, then you can transfer, you can resist, you can increase your tension force. You get my point? Instead of keeping like 50 millimeters, if I go for 60, then again my tension capacity will reduce. If I go for 70, my tension capacity will reduce. If I go for 80, so these are all fundamental why I'm saying actually. People are doing the like bolt design. People are doing like steel section design. People are doing aluminum design. People are doing what you call actually the RCC design. Because in the absence of this funda actually, they will keep on trying for the whole day, the section is not passing. Will not pass. Because you don't have the basic fundamentals actually to get you an understanding which could be solved within an hour actually you spend on a days of days which you could not able to solve. That's what the basic funda. Because you don't have the what do you call propaganda to understand what is the situation actually, rather than you only keep on applying the formulas and the equation. You get my point? I'm going to erase this actually. You can go for 50 if it is steel section actually you can go for 50 millimeters in general. 50 millimeters, because this is only for the purpose of like to tight the bolt. to tight the bolt. But you can go up to 100 millimeters. The maximum you can go up to 100. If you go more than that, so automatically your base plate size actually everything will bigger. I mean, and it is unrealistic actually going with the section sizes such a huge base plate. So that will be like more unrealistic. It is not constructability useful, which will go for it. You get my point? I'll erase this. Huh? Clear, right? Fantastic. Okay. So what we have seen actually, we have seen is what? We have seen is materials, right? Second one is what? Section sizes, right? Third one is what? Loads. I have to apply the loads, right? Actually, correct? I have to apply the loads. And what are the different types of loads is there? If I ask people, actually, they will directly say dead load, live load, wind load, seismic load. The different types of load is only two. One is gravity load, another one is lateral load. That's it. So two different types of load, actually, two application of load is what? One is gravity, another one is lateral load. Under gravity, you would say like, what do you call dead load, then HDL, then live load. If I go for lateral load, then I'll go for what? Wind load and seismic load. Okay. If I go for dead load, what is that actually? It's called what in general? Self weight of structure. Whatever you do have with respect to the density of material, automatically you can calculate. For that, what you need to understand the density of material. Correct? What is the density of concrete? Correct? What is density of steel? Yeah. What is density of aluminium? Correct? What is density of actually what do you call screed? Correct? Yeah. What is density of lightweight block wall, which is ACC? Yeah. 7.5 to 7.5 to 10 kilonewton per MQ, 750 kg to 1000 kg per MQ. So these are all in general material what you are using in the constructability. If you want to have a glass, which is very similar to concrete, almost 24, no? Okay, glass. Okay, marble also it is same, 24 marble density, which is similar to what you call actually the concrete density. The fourth one is screed actually. You'll have a screed in below tiles, below marbles actually, those kind of things. Okay. And what is next actually? The next is what? XDL. XDL is what actually? It's called super dead load, right? Super dead load is what? Is the combination of block wall, okay, and finishes and MAP collateral load. MAP collateral load. Okay. Block wall, it could be different, right? Actually, we do have three kind of block wall. One is either it could be like lightweight blocks, which is AAC, or hollow block, or solid blocks, right? Actually, and the red color thermalite block is there actually, but we are not using nowadays. We are instead of that we are using white color thermalite block, white color solid thermalite block. Okay, it's a lightweight basically. It's called aerated block, autoclaved aerated blocks. Okay. So if I go for block wall, if I go for AACC, which is AAC, the minimum load I have to consider according to the municipality requirements is 2 kPa. What is kPa? Kilonewton per square meter. Note this point. These are all part of manual calculation when you're going for the examination. Okay. These are all okay. If you are lucky, you will get such kind of easiest question. If not, you will get the harder question. Okay. So 2 kPa is what actually 2 kilonewton per square meter. If I go for a hollow block work, then this 2.52 becomes is what? 3.5. 3.5. What is finishes? Finishes, it could be different. Either it is tile finishes, marble finishes, only screed alone, or no finishes. No finishes you will get only in the parking area. Correct, actually. There won't be any finishes in the parking area. Though you do have a different finishes, as per municipality requirements, you need to assume the minimum finishes load according to the marblage. This is the requirement, and this is what it is mentioned in the DBC code, which is called Dubai Building Code. Actually. Once it is finished, I will show you bit of presentation actually, and a very important, which will be quite useful in order to appear for your examination. I mean, and of course to help you for your future career actually, because we created in such a way the presentation what exactly it is useful only to relate it to the structure. So you got my point. Okay. So if you go for finishes, again, it is what? 2 kPa. Okay. Then MEP is what actually? MEP is the collateral load. People are misunderstanding this. MEP is what actually? I do have heavy equipment, or it could be AHU, it could be FAHU, it could be chiller. Those are all local load which is going to be applying only on the particular place. Either it could be roof, or it could be somewhere in the mechanical floor, or it could be somewhere in the basement actually, where I do have water tank. You get my point. So those you don't get confused. Which I'm talking about here, MEP collateral load is what actually? It could be hanging duct actually, what do you call electrical trays, or false ceiling, which is inclusive actually. So all those things which is comes under what? It's MEP. That's the reason we used to call it. It's called MEP collateral load. We don't call it as it's a pure MEP load. Okay, it's called MEP collateral load, which will be 0.5 kPa. Okay, 0.5 kPa. So the moment when you go for SDL, if you just go for add together actually, so it will become 4.5 kPa. Okay, then this one 2 and 0.5, and this has become what? 6 kPa. So the only difference is what I mean, the block work. Okay. If you go for lightweight block, then it goes to, okay. If you go for a hollow block, actually, it will go up to what? 3.5. So the difference of this 1.5 will have a drastic difference actually in order to optimize your section sizes. Now the people I'm not telling you, actually, but in general, that's what they're in the market. Actually. The people, in the absence of the basic understanding, I mean, are completely relying on the software actually, and they don't know what exactly do we need to consider prior to design the structure. When the plan comes, actually, I will just mark some column. I will build the E.T.A.X. model. It's not the way. It is a way to understand the architectural plan where I need to place the columns actually. Do I really require to place what do you call all the columns is continuous, or somewhere I need to stop the columns with respect to architecture to introduce my what do you call planted columns. Okay. And those planted columns, it is supported where either it is supported by transfer beams, or is it supported by transfer slabs. Okay, these are all what it is an understanding. It comes when you understand those kind of fundamentals, those kind of propaganda. So directly going to, of course, software is important. I'm not denying it. Software is important in order to design the indeterminate structure. That's what I told you in the beginning. What is the difference between determinate structure and indeterminate structure? Okay, but in general, if you don't understand the basic concept, I mean, then what is the point of to use the software? The software, whatever is giving the results, you will take it. And you will not come to know whether it is right or wrong. You get my point. Okay. So in order to know this, you need to go for the manual calculation to make it, to build your structural concept is very strong. You get my point. Okay. That's where it is going to become up. Then, and simultaneously, if you learn the softwares of E.T.A.X. and SAFE and STAT, then you will build your career is so strong in a way that actually you can easily competent with 10-year experience to 4-year experience. You get my point? So what now the gap is what actually, sorry, he has a 10 years experience actually. How do you say this 10 years experience? He is super duper master actually. Okay. When you do have only 4 years experience actually, you cannot compete in. Can you tell us actually? So it's not the way to compare with the experience. It is the way what is in-depth knowledge which you have it actually, and what he has the knowledge actually acquiring the basic of 10 years. That's more important. was spending this 10 years actually somewhere in other field actually, or somewhere in the site actually, or somewhere as it is like, by using the software for whole 10 years actually, it does not make any sense actually, which he can able to competent to you. Okay. But your basic understanding is what I mean. You're going to build your career with respect to manual calculation to correlate with the softwares. Okay. Then whatever it comes actually, you can easily go for it. Okay. I'm not denying site experience is not required. Site experience is required to understand the simulate the rebar diameters, how the section size of this looks like, to understanding like, in a real point of like, whether I'm looking for 8 meter span, actually, I can visualize the 8 meter span, which is equal to like, that much length. This is where to correlating with the understanding. But the design basic principle, actually, it will come only through your interest, whether you are going in deep to understand the concept. You get my point, actually. I didn't introduce myself, right, actually. I've been passed out from IIT BTech, actually. I was the gold medalist in BTech, actually, and I was a gold medalist in MTech. Both are from IIT Madras. But the thing is what, actually, to be honest, I'll tell you, for the whole masters, we never use books. Even for whole bachelors, actually, hardly we might have used the books, actually, only in the first year. Okay. In other college, I'm not dominating, I'm not like, comparing with other colleges. I'm only making a difference actually. In other colleges, they do have books, they do have syllabus. Actually. We don't have either books, we don't have either syllabus at all. Actually. Whatever is going to write the topic on that day, actually, that is our syllabus.
And our professor actually only give you the topics actually. Unfortunately, I mean, he won't give you any kind of like, what do you call thesis or reference or books actually where you can study, no. We have to take it ourselves actually to go into the library, to go into like, what do you call referring to the journals, sit in the internet, and those days and all, internet is not like, super fast nowadays actually. If you open Google, it will take 5 minutes. If you go for any kind of like, website, it will take another 10 minutes. You get my point actually. You have to suffer to dig it and to extract actually to present. Another challenge is what actually? That's not the challenge. The challenge is somehow actually you'll copy paste from somewhere. Like out of 30 or 40 students actually, definitely like, 10 students will be like, the front bench student will be there. The 20 students actually what we used to do will copy paste. Okay. But the thing is you have to present. The question is what actually, you will not get the same topic as those professors are very clever actually. Fortunately, also from like, what do you call the same college only. And these people are very clever in such a way that actually you will copy from the beginning, that he will give you like, different topics to everyone. And go on like, find and dig it by yourself at different topics. You get my point actually. And different topics and digging it actually and presenting in front of to make them to understand. You presented actually, that's what? No. You presented and asked the question actually, and you have to answer. At what level you are only like, second year or third year. Imagine it. Okay. These are all like, to build your career, to understand, like, to go for it. Okay. You get my point, what I'm trying to say actually. So this is where the core concept actually and a basic understanding will come. What I'm trying to say, we'll never use the books. Okay. And to be honest, we don't have any syllabus. Not for the bachelor, neither for masters actually. Up till now, if anybody asks actually, can you just give me the syllabus actually? We don't have syllabus. We will come actually, we'll give you 4 topics actually in a day. Next week you'll come, you will give you 8 topics. Okay, this is for 1 month actually. You go on dig it actually and present so and so date actually, and this is what you get my point. This is where we come up actually to just get the basic understanding. The moment these things are very strong actually, okay, then whatsoever you say is 10-year experience, 15 years, 20 years doesn't matter. You can easily competent because your skills are much more and a basic understanding when compared to others. You get my point? That's where you need to competent. So to become like him, actually, do I need to spend 10 years? Actually, I don't agree this. Okay. These are all like, how you're building your career, in which way you have been like, coming up into the career. Actually. That's more important. Okay. So might be like, some of them are super duper in the sites, correct? Actually, he's been like, equal whole things. He's been like, all in all. Okay. Design into the site and everything because I know him. Imagine if I just, go and join with him as a junior actually, then he is like a mentor and he can guide me properly, correct actually. That's the one way of things. Assume if you don't get such mentors, then what you will do actually? You have to dig it, you have to like, study. Or else actually, whatever he learned from others actually he will teach you. Might be it is 50% wrong actually. Or you are going directly relying to the some other like, third party softwares or kind of things actually, and to build your career as it is like, to go for it. Okay. So coming back to this, so this is what It's a SDL actually. So if you don't reduce from the beginning in a structure, so what exactly the load which you're going to apply, I mean, you will never get the word called optimization. Optimization. You know what is the construction value, especially the structural discipline? 40%. The overall cost, whatever you say is it's 100 million, 200 million, from the overall cost, the majority of the percentage, the structure alone will take it, roughly 40. The remaining 60% you might say it is only for two discipline. No, it is plenty of other discipline actually. Architecture actually people are thinking only like, the block walls. No, architecture will have a sub-discipline which is the interior design. Okay. MEP, it's not MEP, mechanical, electrical, plumbing. So totally 5 discipline is going to be like, spared by 60%. So roughly, which is only 12.5%. The guy who's been only taking 40% alone is structured. Okay. The reason why I'm telling, I mean, since from the beginning, while you're doing the design, if you don't optimize, you will directly expose. To completing the design, actually, they will prize you. They will say, actually, sir, I never seen such kind of super designer in my life. Actually, whatever the architect said, actually, he did not even deny. He's directly like, accepting. You get my point? Because I don't have concept actually. I don't have answer. I don't have debate. I cannot say anything. What exactly he asked actually. You get my point actually. Whatever the architect say, I will say yes actually. Okay, because of my lack of knowledge. Now the question comes actually, somehow you will finish it up. Because whatever you do, software will give you the result. That's what I used to call garbage in, garbage out. Whatever you do, software will give you the result. Isn't it actually? You use any software. What software will give you the results actually? I'll make you another fundamental, you will be enjoying it. Okay. The what I mean, like, instead of 200 sections, software will give you 400 sections. And you will keep on arguing only those actually. What is the point thing, like, to go for 200 to 400 actually? You will not caught in that point. You will caught actually when the BOQ has been released. And the bill of quantity has been released actually, you will directly caught because as 40% is been accumulated only for structure, actually, you will be directly exposed. And your cost will be higher than the others. And then people will say, you did completely like, what? Over design. You get my point actually. You will completely what? Over design because of your lack of understanding. Now what? People doesn't know how to choose the column size as well. Okay. How to come up with the column size, how to calculate the beam dimension initially. Okay. Because you don't want to dig it to the code actually, and you don't want to refer any reference actually. Okay. And you want to go for always with the thumb rule. You get my point? Because the reason why what he thinks actually, software is that whatever I'm going to model, it will give me the results. Okay. This is where you need to like, what do you call strengthen your career. Let's say like, I'll go for this other things, which is called what? Live load. Live load is what actually, it depends on the discipline. It depends on the discipline of the structure. Okay. What one is residential unit, another one is commercial unit, another one is office unit. The unit is what it's called building, right? It could be residential building, it could be commercial building, it could be office building, it could be hospitality building actually. It could be like anything which is related to navy, military, like a special kind of like isolated buildings. But mostly we will end up with these three buildings, right? Actually, either it could be residential, or it could be commercial, it could be office, or it could be industrial when you go for steel structure, isn't it? So when you go for residential, there you need to understand, I mean, so again, do I need to refer any reference or anywhere in the DBC code? Actually, no. This is comes to the reference of American code, which is AAC7. What are the codes we are talking about actually? The codes we are talking about here, ACI 318, ASCE 7. Okay, ACI 318. These are the only two codes actually which are going to refer it in order to design the structure. Okay. Don't bother about because each code will have like 600 pages. Okay. If you start reading from today, actually it will take minimum 6 months, I mean, to complete. Okay. And not only that, to understand another 6 months will take it. So we'll give you like the cream will give you like the very important the extraction, what exactly is required for your career, what exactly is required for examination. You get my point actually. You don't need to dig it all those things because out of 600 pages, actually 300, 400 pages only explanation, theses are kind of might be it is only required for 100, 150 pages. Out of 100, 150 pages, which will structurally useful for only few pages. You get my point. Okay, so residential unit is what? 2 kPa. Of commercial is what actually? 3 kPa and 2 kPa. And office building is what? 3 kPa. Okay. Residential is 2 kPa is nothing but what? 2 kilonewton per square meter. If you just convert into kg, which is called 200 kg per square meter. Okay. Try to understand it's a very small conversion. From kilonewton to ton, it is divided by 10. Okay. From kilonewton to kg, you are multiplying by 100. Okay. Only two conversions. It's very simple.
So 2 kPa, commercial is 3, and office building is a what? 3. Commercial, it is a combination of residential plus office, correct? Wherever you do have office building, you will apply 3. Wherever you do have what do you call actually residential, will go for 2 kPa. It's clear, right? I'll erase it actually, just note down. Right? Okay. What next actually? Lateral load, right? One is what? Wind load, another one is what? Seismic load. If we talk about wind load, I mean, the basic important is what? Basic wind speed. Okay, basic wind speed. Okay. The moment when you talk about lateral force, actually, it is all two things. One is static, another one is dynamic force. Whenever you are just what you call talking about lateral force, you do have two things. One is static force, another one is dynamic force. Okay, the basic wind speed. Okay, as per DBC regulation, it's 38 meter per second for 50 years of lifespan of the structure. What is the lifespan of the structure? In general, in Dubai, 50 years. Okay. It doesn't mean that actually, I don't do any maintenance. I can just, keep on leave the structure as it is 50 years. No, you have to do periodic maintenance. It means what? You have to do periodic maintenance. The whole life period of the structure is 50 years in the sense it is a demolition point. So after 50 years, I cannot keep the structure. I have to demolish. That is what it meant. That is what it meant. So 50 years of lifespan of the structure, the basic wind speed is what? 38 meter per second. 38 meter per second. Okay, those things, I mean, I'll give you a bit of explanation. I do have a PPT. Okay, so let me go for seismic load actually. Seismic load, it is a very generic thing. You know how the seismic is generated, right? Okay, how the seismic is generated actually because of two main reasons. One is volcano eruption, another one is dislocating of the earth plate, right? Actually, these are the two main. There are so many other reasons actually. I'll give you only two main reasons. Okay, so when you go for what do you call seismic, so it will be fall under different zones, right? It will fall under different zones, isn't it? It's starting from zone 0 till zone 5 actually. And finally, I need to calculate what? Seismic force. Okay, what is seismic force? M into A, right? Mass into acceleration. Mass is what? The existence of structure, it is called mass, correct? The existence of structure is called mass. Okay. And the acceleration, of course, I mean, to drive the forces from one point to another point to drive the forces, which is called what? Acceleration. How the seismic force are what do you call transferring? As kind of waves, isn't it? Okay. Let's talk about it. It is very generic actually. In Middle East, actually, we are only following about 2A and 2B. Okay, 2A and 2B. When you have to use it 2A actually, when you are going for designing the structure less than or equal to 10 floors, it is 2A. When you're going for greater than 10 floors, it is called what? 2BH. It's called what? 2B. Okay. And I'll give you what all those parameters and coefficient actually in the PPT because I don't want to confuse you. Okay. Just note down if you want these things. Finally, next is what actually after load. It's called what? Load combination. The load combination is what actually? Two things. One is ULS, Another one is SLS. ULS is what actually? It's called ultimate limit state. SLS is what? Serviceability limit state. And a very simple way of understanding is what? ULS is always with the factor of safety. SLS is what actually is without factor of safety. Okay. What does with factor of safety, without factor of safety? This could be one or more than one actually, and this could be one or less than one. That's very simple. Okay. Now the question comes actually, it's not about the factor of safety. The question comes, I mean, where should we use ULS? Where should we use SLS? This is where the contest. This is where the basic understanding of using the combination. You get my point? Okay. So the moment when you say ULS, actually, as per code, according to the standard, you have to use for designing the structure. Whenever you're designing the structure, you have to use like what? Ultimate, which is with factor of safety. The moment when you say without factor of safety, actually, when you're checking only the stability of the structure, then you'll go for what? Serviceability. Okay. So what is stability of the structure? I would say the stability of the structure is what? Deflection. Yeah, fantastic. Settlement. Okay. Deflection, displacement, drift, and settlement. Okay. Now another challenge is what actually? These are all generic theory, right? These are all generic. When should we use SLS? Okay. When should we use SLS? What is the question? These are all comes under SLS, which is basically called what? Serviceability check or structural stability check, whatever you can say. The right word is what? Structural stability check. Structural stability check. Okay. The structural stability you're checking by what? By using serviceability combination. Structural stability you're checking by what? By using serviceability combination. Okay. So one is what? Deflection. Second one is what? Displacement. Third one is what? Drift actually. Fourth one is, as he said, fantastic. It is called what? Settlement. Okay. The moment when I go for deflection, actually, the allowable deflection, I should know the threshold, right? I should know the benchmark. Then only I can correlate or I can compare while I'm designing the structure whether it is safe or not. Correct? If I don't know what is the benchmark, if I don't know what is the threshold actually, then I can keep on leave the structural section to deflect. Now, what is the pointing out actually? I don't want to see those deflection. Correct? If I don't want to see those deflection, it is going to be considered as safe. Isn't it? It is going to be considered as safe, which is structurally safe. Here, I'm not talking about any reinforcement inside the section. Note this point. Huh? I'm only talking about the stability. Only I'm talking about the sizes. Okay. Still, if it is not very clear, okay. Still, if it is not very clear, what I'll do, I will delete this. Okay. What is the deflection equation for simply supported? This is the formula. Okay. Don't go into it deep. Actually. I'll try to make you an understanding of this equation. This is the deflection equation, correct? For simply support. Assume I'm going to design the structure. Whatever the load which is specified in the code, I have to consider, correct? So it means what? Load will never change, right? Assume architectural plan it's set. I have to follow the same. In that case, the span is going to change? No, right? Alas. E is the modulus of elasticity. Whatever you have been correlating with the concrete grid, that's what. Either it could be 40, 50, or if it is structural scale, whatever it is there, actually you have to assume. What is in your hand? It's a stiffness. Moment of inertia is called what? Stiffness. Okay. And this stiffness is what? Okay. BD cube by 12. Fantastic. BD cube by 12. Even someone has been waking up from the sleep also, we will just inform them because this is by default, by memorized, by heart equation. These are all correct. how you've been like, saying A plus B whole square. These are all by default, by heart equation for civil engineering, BD cube by 2. This is my beam, correct? Right? This is my beam, correct? Test. I'm going to apply the load. There is a support here. There is a support here. Okay. What is BD cube by 12? B. D. Correct. Fortunately, I cannot keep this beam like this. I have to keep this beam like this. In a reverse. Same beam, huh? Same beam. But due to the site constraints, okay, due to the site constraints, I don't have space to keep this beam like this. Try to understand, huh? Then this is the beam, correct? Again, the D is what? This is the D, right? That is the equation. This is the D, right? And this is what? D, correct? Because I only resolved the section. Totally wrong. This is what your understanding. This is what the correlating of your concept. Totally wrong. The element, the direction, the one which is going to take the load, that is where you need to make it cube. The cube which you're doing, the cube, D cube, the direction, the one which is going to be resist the forces, that is where you're making as cube. That's what the formula is pretending. Totally wrong. If you do it again, actually the way of understanding is correct. What you said, sir, I only resolved in the beam. You're getting a point actually. Sir, same section. What is the pointing out? It is a D. If I keep it this beam also, it is a D. Right? Correct. But in terms of you're going the structural concept to apply those into calculating the stiffness, totally wrong. The reason why, if I have a deeper section actually, you will have a less deflection. Here the section is small. The one which is going to be resist your forces only the width side actually. Your deflection is going to be like much more higher than this, isn't it? To control your deflection in a basic funda is what actually I need the depth. I don't need the width. To control your deflection, the basic fundamental, the basic concept is what? The D should be higher in order to control my deflection. Okay, I'll tell you another question. Why always the warehouse structure? You might have seen the industrial structure. Okay, why they are going for rafter? This is a rafter, right? This is usually called as rafter. Whatever it is, you call it as beam, you call it as rafter, doesn't matter. Okay, the main beam. Okay, why they are going always UB instead of what do you call UC? If you go for UC, there's also what, right? Actually, UC, the weight is more, it will get passed in the design edge. The reason they're going for UB in order to get the more stiffness in terms of depth, correct? If you get more depth in terms of like, the direction, automatically it will be satisfying the deflection. Okay. The design comes after, prior to the serviceability check. If I need to make sure my structure, it is stable, structurally safe, then I don't need to check for the design edge. The people are like, having the misunderstanding of the wrong concept. The once the analysis is finished, they want to directly go for design. This is entirely wrong. This is by yourself, you've been like, taking out the lack of knowledge, completely ignoring the design. The moment when you finish the analysis, you have to go for serviceability check. If you don't check the serviceability check, there is no pointing out to perform your design at all. You get my point actually. Now I'll give you another contradiction. Okay, there is a building of 10-story, which you are going to design it, the moment when I do the analysis, what they have, the debate is what actually I'll perform directly go for design. Okay, because I need to satisfy, I need to check the section whether it is safe or not. Of course, I need to see like, what do you call columns and beams and slabs, actually all those things. What is the required reinforcement? Because ultimate my aim is what actually in order to calculate the reinforcement. Ultimate aim is what in order to calculate the section sizes, correct? Actually, that's what my ultimate aim. Ultimate aim is what actually in order to calculate the section sizes, in order to calculate the rework, correct? Okay, because I need to prepare the drawing, I have to give it to the site people actually to execute or to the municipality to get it approved. But before that, everyone is missing the concept is what actually it is the structural stability, the serviceability criteria to make you an understanding, to make you into the shape of the building of deflection, displacement, drift,
And as he said, actually fantastic, it is called settlement. You get my point? If those things are mean, you did not check actually, there is no point in to go for like to further carry out the design. Okay. Now the contradiction is what I mean. I'm telling you, out of 50 columns, the 10-story building actually, 6 columns is fail. Assume 6 columns is going to fail. Okay. Only in terms of structural stability. But I'm just giving the contradiction is what the whole building is safe. The whole building is safe what in terms of stability. It won't bother this 5 columns if it is failed under the serviceability criteria, because under the serviceability criteria, I'm not going to check the design. Serviceability criteria is one going to check the entire structure stability. That is where we are talking about in terms of deflection, in terms of displacement, in terms of drift, in terms of note this point actually. This is one of the questions from the municipality examination. If you talk about deflection, it is span by 240. Regardless of span, if you're talking about like the benchmark of threshold to make it safe of my structural element, it is called what? Span by 240. If it is under the limit of span by 240, actually, it is safe. You get my point? And I'm not telling this is what the code says. Okay, you cannot assume by yourself. Whatever it is there in the code, actually, that's what. It is regardless of fixed support, regardless of simply supported, regardless of continuous beam, whatever it is, the span which you're talking about, support to support. That's what span by 240. When you go for displacement, actually, it is called H by 450 to 500. See the understanding. Here you're talking about the span, here you're talking about the H. Okay. The difference is what I mean. This one, you're talking about the vertical deflection due to gravity. The displacement, the one which you're talking about, it is due to lateral load under the case of wind. Under the case of wind. The moment when you go for under the case of wind, definitely have to have for like the whole building height instead of having the span. Try to understand. Okay. This is where like you're going to be like try to understand the core concept of the structure. Again, the drift also same, because the drift is what it is due to seismic. The seismic is going to be happen right below the building. We don't know whether it could be 1 kilometer, 2 kilometer, or even 500 meters, or even if it is far away completely. Actually, whatever it is, it has an impact. It has a dynamic impact to the whole structure. I mean, though it is there actually, you may likely see like I'm really sorry to say this, Myanmar and Thailand actually. So many places you might have the earthquake, right? Actually, okay. These are all. There are two other reasons actually, but one is this like drift. Might be like the guy who did not check properly for the drift. Actually, the one which has happened in Myanmar. Okay, the Myanmar is what I mean. It is in a drastic situation is actually under construction building is collapsed. Nowhere under construction building will never collapse. Okay, this is where you need to understand the core concept. Do you think under construction building will collapse? Okay, when the force comes actually, the complete structure will have entire mass, because that's what we are talking about. The seismic force equal to mass into acceleration. Correct. So in order to calculate the seismic force, I need the entire mass. If the mass is more, automatically my seismic force will be high. Correct. This is what the correlating the understanding from the beginning. I need to reduce the mass. Okay. Sir, can I reduce the mass? How can I reduce the mass? Can I take it 2 flows? No, I'm not telling like remove 2 flows, remove 3 flows, or put it extra 2 flows. This is a designer concept actually. This is a civil engineering basic concept of me to reduce the mass in terms of material, in terms of density. Okay, that is the reason we are going for, instead of like hollow block work, actually we are going for lightweight block. You get my point. Other finishes I can go for marble instead of tiles. Okay, so wherever possibilities are there, I can reduce the mass. So what is the impact I am going to get actually? Automatically your whole dead weight is going to be reduced by reducing the section sizes, because you reduce the ultimately the superimposed load which is going to be act on top of the element. Superimposed is the English terminology. Don't get confused, because luckily being as proud to be civil engineer, 80% of the terms in civil engineering, it is English terminology. To be honest, I'm telling you. One-way slab, two-way slab, superimposed dead load actually. Live load is what impose. These are all completely 70 to 80% is English terminology. But people, I don't say like blame the professor, because thing is they don't have time. The funny is what, out of 6 months of your semester, actually 2 months will be holiday. Out of 4 months, actually remove Saturday, Sunday, another 2 months will be gone. Another 2 months, actually, you will not be like present to the what do you call college. Another 1 month will be. So within 1 month, if they want to finish the semester, actually, how could they cover like entire thing? You get my point. The thing is what actually they want to like give you a whole concept, but they don't have time. Okay. The 70 to 80%, luckily to be proud, It's all whole to make you a very clear understanding of what English terminology. But if you try to understand in terms of concept oriented, like formulas, equation, then you will be confused by yourself actually. Then you will stuck over there. You get my point actually. Okay. So going here again, coming to the point is what actually the simply supported deflection is 5 WL for 4 by 384 EI. The I is what actually either you call it a stiffness or moment of inertia. Okay. This is the whole concept. Don't buy not the equation. I'm trying to give you the entire structural concept by using this equation. The I is what actually BD cubed by 12. The moment when you keep the I in the as it is normal and a constructability procedure, I'll keep the I is right in the rafter, in the beams, in the steel structure, whatever you see, I have to place like this. Correct actually. Okay. Due to the site constraints, I'm going to rotate this I beam into 0D. Okay. Then you will get the D is what? This is the D and this is the D. Okay. If you want to make it cube, then you have to make it cube this, not to the depth. The moment when you make it, automatically your deflection will increase it. You get my point? I'll give you another example. Say I have what do you call 2 columns where my steel beam is supported, existing structure, assume existing structure. I have a load of assume 1 ton per meter or 2 ton, doesn't matter, whatever the load you assume. Okay. But the problem is what? This is an existing beam. The existing beam can resist only 1 ton per meter. 1 ton per meter. Okay. The condition is what actually I'm going to increase the load on top of it. Might be I'm going to keep it slab, or I'm going to keep it any machineries on top of the beams. You get my point actually. So what is going to be happen? Simultaneously, this beam is going to deflect, it is going to bend, and it will fail. Correct? That's what is going to be happen. Of course, it's a very straightforward question.
I cannot remove this beam from the site, because if I remove this beam, so many other architectural features it will affect. Assume that this is the question I'm talking about. So many other architectural features is going to be affected. So I have to keep this beam. At the same time, I cannot introduce any additional column to support as well. Hey, any kind of people, if you ask me this beam is failing, actually what you can do, sir, put additional support. The second answer will come, sir, put the knee bracing. Actually. Put the bracing in the both the end, actually, then it will pass. So both the answer is correct. What I'm trying to say, actually, both are not possible. Actually. Both are not possible and not feasible as well. Now what you will do? Now I'm throwing the question to you. Try to understand the question. So very simple question. There is an existing beam. Assume 8 meters. I'll give you the number as well. This is the 8 meter of existing beam. Okay. There are 2 supporting columns. Fortunately, I'm going to increase the load on top of the beams. Okay. This existing beam is not going to bear the load. It will directly fail. The moment when I keep the extra load, the beam will say, what do you call actually? Salam alaikum will fail down. That's what you will do. Then how do you strengthen actually? No. Assume it's the steel beam. Assume it is a steel beam. Okay. How do you strengthen? There is no way to add the columns in between. There is no way to add the supporters. These are all straightforward answers. Correct? Even the people who are having the experience of 10 years without having the civil engineering, those people also, they can directly tell you this answer. Correct, isn't it? Add the columns actually, of course it will pass. Okay. Assume there is a big door opening actually. Okay. Big door opening where I'm going to keep my truck. So do you think if I add the columns actually will I able to pass the truck over there? Okay. Assume if I added the bracing here, if I keep able to keep the truck, that is also obstructing. Correct actually, because I need the free space actually. That is where I design in such a way that the architecture I need the space, right? But fortunately, I'm going to increase the load. Thing is what? This is where you need to see moment of inertia. I is what? You are increasing the stiffness. That's what I said actually. I did not read it as moment of inertia. Please note down. Actually, I is for moment of inertia, but I read it in a different word called stiffness. Did anybody read it? Did anybody notice that actually? I did not read it as moment of, actually it is moment of inertia, but I wanted to give you direct concept. I read it as stiffness. The stiffness, this here, it's not sufficient to carry the load. What I'm going to do, I will add the extra plate to be welded to the I-beams. Okay. It could be anything. It could be 12, 16. I'm not talking about here what is the thickness of the plate. I'm giving the direct concept, okay, without adding any column, without having any bracing actually, how this I can satisfy by keeping the existing beam as it. The moment when you know, automatically I don't need to teach you. What is the moment of inertia of this? BD cube by 12. What is the moment of inertia of this? BD cube by 12. I will add it together. I will check the deflection. That's it. You get my point. Here I don't need to teach you. Because if I give you the concept, that is more than enough actually. You yourself, you will calculate. What I did actually, I only wrote this equation. Okay. I said this I is what? Whatever is going to be resist the load actually, it is the I. Correct? And what direction is going to resist the load? That is the D. So I made it clear actually 2 points. The third one is what actually, this beam is not going to be sufficient for the extra load. So what I'm going to do, I will add the plate right below, correct? It could be 12, 16, 18, doesn't matter. So what is this? BDQ by 12. What is B? 18 millimeter, 20 millimeter, 16 millimeter. Now what is going to be happen? I will add it this two because this two element is going to be resist the load, correct? Yeah. So now I will check the deflection accordingly. Correct. What happened actually? Then you need to refer the books, you need to refer the journals, you need to go for experience. These are all understanding of the concept actually. How you need to solve in a different kind of always you don't get what you call direct, straightforward the design. You may get such kind of challenging as well. So I don't say it is a challenge. It is only the concept oriented. Okay. Here there is no challenging. Okay. What is the challenging here? Sir, I'm going to add the plate. Who said actually if you're adding the plate, it is a challenge? It is a challenging for the contractors, not for the design. It is a challenging for the contractors actually in terms of logistic, how you're going to erect this plate on top of it actually to keep the welding. Because you said you cannot remove the existing beam. In that case, you need to lift this plate, to keep some kind of temporary props and support to just do the site welding. It's zero challenging for designer if you do have proper understanding of the concept. And it is a complete challenging for the contractor actually, how he is going to do the erect display. Okay, you're putting the entire trouble on contractor, you will be safe. But for that, you need to be very strong enough. Correct. Okay. Instead of that, no, sir, you need to add the columns actually. There is no way actually. If someone on top of you said actually, then you don't have concept. There you felt, I mean, where you are standing. You get me? No, I don't want to degrade that. But that is what the fact. The fact is, this is what actually, because so many people are degraded when we started actually. Of course, when you started your career actually, you're not born and brought up of design, correct actually. As such, you're learning and you're coming across, correct actually. But for that, what you need to make it yourself in a very strong of concept oriented. The moment when your concept is very strong, actually, I'm telling you, no one can compete it. Whatever you say, 10 years, 15 years, 20 years, doesn't matter actually. As long as your core concept is very strong, actually, you can top of on top of him in very soon. Okay. Software is keep aside. Software you can learn easily. Of course, you need to learn the software. Okay. Software, you need to be correlated. That's what I said, determinate structure, indeterminate structure. In order to go for indeterminate structure, you have to use a software. There is no way. Okay. If there is a 3D building is there, if there is a 3D industrial structure is there, if it is high-rise building is there, I have to use a software to calculate the forces each and every column because
it is going to be changed for each and every column. The spacing between the columns, the spacing between the support is not going to be same. Correct. I'm not going to get any kind of structure in terms of architecture actually 6 meter, 6 meter, 6 meter edge. Correct. If someone designs 6 meter, 6 meter, all the columns will fall under what? Bedrooms and halls only. Okay. Some column base will be falls under 6 meter. Some column base will fall under 8 meters, 9 meters, 10 meters. I have to direct all those things. Correct. That's where I'll be there as a designer. Isn't it actually? Okay. But you need to understand in what way I can solve those kind of things. Yeah, if you want note down, I'll just remove this, right?
Can I remove this? Give me 2 minutes. Sir. Hmm? 5-10 minutes. Yeah, another 5-10 minutes. I was supposed to give you the break actually, but I don't want to give you in the first class itself actually full of. Second class animals actually will go for direct problems. We'll go for column design, like slab design and everything. Directly we'll focus on like what exactly is required for municipality examination. Okay. Yeah, they will give you. Yeah, they will give you like printed copies actually. Okay. So it's easy for you actually. You don't need to write it all those things. First class as you write actually it is okay. Second class animals actually you don't need to write all those things in the board. Okay. So they are going to share you all the printed document with you. So you can have it the printed documents actually. You can only refer it. If at all you required actually anything more important, you can write it over there in the paper itself. Okay. Then you can only purely concentrate what exactly like I'm going to share the knowledge. Okay. I don't tell you like I'm going to teach you. Always we use toward the called we're going to share the knowledge. Whatever I'm going to like share the knowledge, you just take the notes of it in the paper. The soft tools I'll discuss with them. Yeah, I'll discuss with them. I'll get back. We will go for what do you call for concrete. Okay, ETAPS, safe. These are the two softwares for concrete. Okay, then for steel actually it is called what? CAT Pro, Master Series, Idea Statica. So these are all three softwares. But addition to this, there is one more software called Procon and the Procon here. Okay. These are all the softwares actually for concrete and as well as for steel part. Okay. So let's talk about like weld capacity. Okay. Assume I have a steel column actually. Okay. And steel beam here. Okay, steel beam here. So this beam is what actually? UC 203, 203. Okay. Regardless of any weight, it could be 46, 83, doesn't matter actually. So it's 203, 203. Assume this column also 203, 203. I did not mention any weight here. Okay. Will directly give you the forces is what actually. Always I told you, right? The indirect tension is much more higher than the direct tension. Correct? The indirect tension, which is going to be comes from what? Is going to comes from moment touch. Okay. Assume I have the moment is what? 80 kilonewton. Okay. I don't want to go for bolt joint. I have to go for welded joint. Okay. So core concept, huh? Core concept. For that you don't need any equation. Then and there in the site you can calculate, you can erect it. Sir, how can I do it actually? Because I'm a contractor. I cannot design the weld actually to get it. So many temporary supports it might require for the contractor to erect the permanent structure. You get my point actually. So many temporary support, even for the actual steel column and steel beam, to require in order to erect the heavy structures. It could be this scenario, it could be any scenario. It could be any scenario. Okay. There you might calculate the moment actually, or you calculate the forces actually. Okay, those are all things we'll see in the next class. I mean, what are all the moment equations are there? Okay, I'll go with the number directly, 80 kilonewton meter. So what it does actually, this beam is going to fail this, correct? The beam is going to rotate. Beam is going to rotate. And what is the lever arm? This is the lever arm. Correct? So that is where the tension force is created. Tension force. So tension equal to moment divided by lever arm. Okay. Moment is what? 80. Lever arm is what? 203, right? Because 203 section. How much it is? Anybody has a calculator, anything? No problem. By phone you can use it. How much? 3, 4. Okay, 348. 348 kilonewton. Fantastic. It's quite high, huh? Tension force is quite high. 348 kilonewton. It's almost 34, 35 tons. 35 tons. Okay. I need to calculate the, what do you call? Like this, huh? This is the column, huh? This is the beam, huh? Correct? The beam is connected to the columns. I'm going to weld it here. I'm going to weld it here. I'm going to weld it here. Correct? Okay. Assume this is 203, 203, 203. You need to minus the flange thickness, but consider actually as far as now. So 203, 203, 203, total 600 millimeters of length of weld. The length of weld is what? 600 millimeters. Assume I'll go for 5 millimeter thickness of the weldage. Okay. So 0. Assume 600 multiplied by 5. What is the equation? AS into FY, right? This is the area of weldage. Length of the weld multiply the thickness, you will get the area of the weld. Area of the weld. Wherever you are going to do the weld. If I don't do the weld here, don't consider only 400. Instead of 600, it will become 400. If I do only weld here and here, I'll take it only 400 inch. I don't take it at 600 inch. Multiply by 420. This is the yield strength of weldage. Minimum grade. Okay. What is the answer? Can you tell me? One, two. Yeah. 000. Correct? Newton. Huh? So 1260 kilonewton. 1260 kilonewton, which is equal to 126 tons. You get my point, actually. I don't need any software. I don't need any equation. I don't need any formulas. I'm there in the site. What is the forces which is going to be act? I can directly calculate what is the length and what is the thickness as well. You get my point, what I'm trying to say, actually. Yeah. This is what the basic understanding of what? The calculation to calculate the weld capacity. Similar way can do the bolt as well. Yeah. Okay. But this is how, as I said, actually, like, it's not limited to the manual calculation. Okay. In examination, you will get the questions of 60% from manual calculation, 40% from software based question. Okay. It's combined together. It is an examination question. You may get the software question as well, and you will get the manual calculation question as well. So once if you're not familiarized both, then you cannot go and pass the exam. Okay. Now the market is completely changed. I'll give you funny, actually, you'll be like, so interesting. My friend who has an consultant, actually, he knows Sarab engineering consultant. There was a structural engineer before, he resigned actually. Okay. And they're looking for a structural engineer. Only the experience of 4 to 5 years. Even the design, actually, if they do experience 2 years is more than enough. not less than 10,000 dirhams of salary, no one is ready to come. Having only G+4 license. G+4 now in the market. Yesterday I was really shocked. Okay. Market is completely changed. Not like before. Huh? Not like before. I'm getting like salary of 4,000, 8,000, 6,000. Minimum salary if the structural engineer want to work in your consultancy firm, even if it doesn't have enough experience, only if he has G+4 license, if he knows how to design it, actually 10,000. And this guy said actually he's asking 10,000. He called us 4 or 5 people for an interview actually. Okay. And he wanted me to conduct an interview. So I was the one actually who prepared the questions I have given to them. Okay. Out of 5, none of them has given complete the whole question answers. Some of them 3 questions, some of them 2 questions, some of them 0 as well actually. But they are writing all the salaries 10, 11, 12, not less than. There is one guy actually too generous, 8K. 8K. That is the guy actually who wrote all the questions is wrong. 0 actually, 8K. Sir, 8K is enough for me. No problem. I'm getting 6K if you give 2K extra actually. The core concept. Imagine actually when you go with the kind of complete core concept actually, and where you will stand. You get my point actually. Okay. And within a couple of period, so I'm not exaggerating the things actually. As such market goes, which we can see, easily you can go for upskill and your knowledge, and you can go for on a different level. You get my point actually. So for that, you need to be very strong. The first most thing you have to take it G+4. That's the basic. You have to take it what do you call, sir, I don't have experience actually, so I cannot appear for exam. No problem. But build your career into the complete basic concept. Without having the manual and correlating with the softwares, you can only do the complete design. You get my point actually. How do you check actually when you do complete the E.T.A.P.S model, safe model actually, when the forces comes, how do you check it whether it is right or not? So if you want to learn it, you need to learn it all together. Then only you can just say, yes, I am on into the structure actually to make them an understanding actually. You get my point. Okay. Fine. If there is any question actually, please do ask me. So I don't want to take much time. Okay. This is the first module. Okay. Of course, we have given much more information. It will be people, some of them actually will bored as well. But I'm not thinking will be enjoyed actually. And for the second module onwards, we'll go directly into the problems. Okay, for the complete core problems. But the second module onwards, it will be like this. We will circulate the hard copies. If you are there in the Zoom, we will give you the soft copy for them. Okay, then you can concentrate actually only, you can only focus what exactly we used to teach. And whatever you do have the papers, we will only go with the same papers. Okay, same papers, same explanation actually, and you can write it then and there what exactly is required actually, and you can go for it. Okay. If there is any questions, please do ask me, then I can just clarify your questions. I'll give you next class, no problem. When you go for the real problems actually, then you will understand more. When you go for the real problems, especially design of RCC column, RCC beam, then steel beam, steel columns actually, the design of both the element, then you will have more understanding. Okay. Maybe in a bit of a core concept, the manual, so you slightly understand. But when you go with the numbers to calculate, then you will be understanding. Okay. Anyhow, welcome to all. Okay, for algebra, and thank you so much for your patience. To be here actually and with us, and hope you enjoyed the session. Okay, the first module, and as I said, second module. We'll go for directly the problematic. Thank you so much. Thanks a lot. And as I said, in continuation to the manual calculation, there is a software also is there. Soon after, they will set up the whole benches and thing. And if you want, you can bring your laptop to install the software. So you can use it actually, no problem. So it is all all those related softwares, as I said, E.T.A.P.S, Safe, Idea Statica, Master Series, Stat Pro. It is a complete package, including RCC and as well as data. The second, I'll call them actually if they want to say anything.
Morning, everybody. So this was our today's session on the introduction of manual calculations. So now we have this 10 weeks course. So this is the first week. And if you see the modules we have designed, sometimes sir can take two module combined in a week to speed up the duration of the course. It depends on the availability of time. So any questions you have, you can even ask in the group. We are going to make a group of of this batch, and then you can ask any questions you have. So we will wind up this. And, there are some students whose registration form you have to fill, and then sign, and then thank you.